Good day. My name is Bitumela Raborolo, a second year Bachelor of Education student in Geography in the Northwest University Mafikeng campus. Today we'll be learning about map work, particularly contours and what they represent. Excuse me, I'll be reading from my screen here. To clarify everything before we begin with today's lesson, map work is a study and analysis of maps, especially prior to or in relation to fieldwork. The most important question for today is, what are contours? A contour is an outline representing or bounding the shape or form of something. It usually represents an outline, especially of a curving or irregular figure. What I have with me here is a topographic map. Students usually see lines with various numbers. Well, today we will be explaining what those numbers and lines represent. These are the lines on a map that join places of the same height. The main aim of the implementation of contours on maps was to assist us in obtaining information regarding the steepness of slopes along with the direction which the land is sloping. What I have again here with me is a contour model. This is a 3D model which represents the contour lines and the contour interval and different heights on a map. This is actually a model where we can actually see what different contour lines and different lines represent. Well, if you can observe closely, we have our scale here and we have our contour interval. If we observe closely, we will notice that every map has a particular contour interval, which is the elevation difference between the adjacent contour lines. The contour interval should always be the same, and you should bear in mind that there are different contour intervals and they should be the same over a single map. What I'm trying to say is that the contour interval represents the height of this particular map. And if we were to look at another map, then another map would probably have another type or another kind of contour interval. There are different contour intervals on each map depending on the topography. If the general terrain is quite elevated, for example, the interval will be about 24 to 30 meters. To make it easier to read, yes, it is to make the map easier to read. So this is because too many contour lines would be difficult to work with. So smaller contour intervals make the map more easier to see, and larger contour intervals make it more even easier to see. So a representation of different landforms on this contour model will be represented by different contours and contour lines. Well, as for the map scale, which is here, we would always remember that the larger the scale, the smaller the place. For an example, a larger scale would represent a small town, and the smaller scale which represent a larger place may most probably represent a province. I will repeat that. For the map scale, we should always remember that the larger the scale, the smaller the place. And the smaller the scale, the larger the place. So a larger scale would represent a small town, and a smaller scale would represent a province. Horizontal distance is found on a scale. As you look at the map, you will notice that the contour lines enclose smaller and smaller areas. Enclose smaller and smaller areas. You must check very carefully. Numbers increase while the circles or the contour lines enclose smaller and smaller. The smallest areas which you can see here, the smallest areas are the smallest circles that represent the top peaks. These are the top peaks, which we can see over here. These are the top peaks. By top peaks, I mean which I have made sure that I make them visible. I have colored them in red so that the top peaks are much visible for you to see. And you can also check the number that represented the top peaks is always high. It is always high. The number that represents the top peak is always high because it is the most steep. It is the most steep slope on that landform. It is the steepest slope on that landform. The numbers represent the elevation at the top peak. You should check the contour lines enclose smaller together, but the number increases, it doesn't decrease. This means the contour lines basically represent ground elevation or depression, but in this case it is an elevation because the numbers increase. But if you look closely here, you will see that the numbers are depreciating, the numbers are declining. When the numbers are declining, this means the landform is shallow. That means the line form is shallow. Elevation, which is happening right here on these three different landforms. Elevation contours are the imaginary lines connecting points having the same elevation on the surface of the land above or below a reference surface, which is usually mean sea level. Contours make it possible to identify or show the height and shape of mountains, the depths of the ocean bottoms, the valleys, and the steepness of the slopes. Well, to simplify it, contour lines mark points of equal elevation on a map. If you trace the length of a line with your finger, each point you touch is the same height. It's the same height. You should check. It is always the same height. It is the same height, which represents the same height above sea level. Which contour lines are closer together on a map? They indicate a steep slope. You can think of the contour lines as the distance between each incline. The closer together the inclines, the steeper the hill. Our map shows different types of landforms which we'll be looking at. There is a rift valley, A. There is a hill, B. And there's a gentle slope, C. Number A represents a rift valley, and number B represents a hill, and number C represents, you can see it's 200, so it represents a gentle slope. These are determined by the contour lines represented on the map, which illustrates different types of landforms. In conclusion, you must go home and learn about other different types of landforms on contour maps. You must be able to identify and analyze contour lines and contour intervals. That will be all for today. Thank you.